Now today what I'll be doing, I'll be writing the programs on the compiler, and then you will be able to see the things that how the programs are run. Therefore, today I'll do at least the insert at end and delete at end, and obviously it will also have a traversal and also include the create a linked list. Now, if you understand this programs, it's quite easy for you to develop this. Therefore, it's pretty simple, and therefore we'll just start from where we left yesterday. Now, let me share your. Okay. Now, this is the program we had done yesterday. Now, the errors that was coming yesterday was very simple errors, which could have been very well avoided, but due to lack of time, I was not able to do that. Now, I'll just show you that how this program is very similar to the algorithm what we have done. Now, you see, I am declaring a node like this. Any problem we keep on asking. Now, this is the node I have declared. I have declared a node as a data part, and the right link and the left link. Now, this class, I will not be using any global variables. Why? Because you being a student of programming, you must know that global variables are not good, because global variables have at risk that any functions can change the value, and it will be very difficult for you to track who has changed the value. Therefore, though writing program using global variable is very easy because you don't need to pass parameters, but that's highly risky and prone to errors. Therefore, we're writing all the programs using local variables. Now, let me show you. First of all, let me check this code. Now, this code is a code to insert at end. Now, here, if you see, I have used two variables over here. One, the refers to the head. That means the refer to the head means the address of the head, or we can also say the start, which is nothing but the start, and the data which you want to insert. Now here I have used a single pointer, just what I have been using in the last in the algorithms. There I was using a star start. This is nothing but a star start type of thing. Now I declare I allocate memory to this for a new node, because the new node is a node which I will bring from avail, and I will call it new node. Then what I did a malloc for this equal to the size of the node, and I declared one pointer temp, which is used to point at the first node and will keep on traversing to the last. Now, if you see over here, I did not allocate memory to temp, whereas I allocated memory to new node. Can anybody say why? Why did I don't allocate memory to temp? हाँ बताओ. Or I should allocate memory to temp also. Yeah, temp is just a pointer. Yeah, you are correct. Temp is a pointer because temp is not a node. It is a pointer to a node. Therefore, I don't have a explicit node to bring from avail to call it temp. I will have a pointer which will point to the start node and will just keep on moving. Therefore, I don't need. If you can do that, you can do also. But there is obviously no need for declaring and allocating memory to that. Therefore, I'm just declaring it as a simple pointer. Then I check if head refresh is equal to null. It means if this is the first node, if that means the node is totally the linked list is empty. Then what I can do, I will check if head ref is equal to null. Then what I am doing, I am putting the data in the new node. Therefore, I will be having a new node and I will be putting data into that new node. The left pointer will be put as a null. The right pointer will also be put as a null. And the head ref will be pointing to the first node. That means what I am doing is that I am going to make a new node with this, which is having the data part, which is equal to new data, which I passed from here. And the left pointer and the right pointer both points to null. And since the head ref is going to the past to point to the first node, therefore I write head ref is equal to new node. Okay. Now head ref is equal to no. These brackets are not necessary. Just this is just given for your. Otherwise, these brackets are not necessary. And then this is the important thing. I return the head reference because once I exit from this program, this function, sorry, head ref will be gone. Therefore, that starting value of that head reference will have to be saved outside the function. Therefore, I return the head reference as a parameter of type node struct node star. Okay, that means the type of this is nothing but struct node star. Therefore, I return the head ref, which is nothing but as equal to save struct node star. But this is only for the first time where that node is not, there is no linked list. But after that, when this enters in the second time, this condition will become false, because on that case head ref will not become null. Now what I will do in the second case, now I have to perform a traversal. Therefore, what I do, I make temp is equal to head ref, which is nothing but point to the first node, and then I start the traversal. While temp of right is not equal to null, temp is equal to temp of right. If you remember, this is the standard line for traversal. That means if temp of right is not equal to null, temp is equal to temp of right. And by this code, it will reach to the end of the. It will reach to the end of the. It will reach to the end of the. Just a moment. Now, it is a standard way to say like that. Now, the new node has come. I will put the data into that. Then I will put the right pointer as null because that is the second node and it has to be null. And then the left part will be joined to the temp. If I write new node of left is equal to temp, and by this way I will be again returning the head ref, because head ref is nothing but a reference of the first node, and therefore I return. Now this is very clear, these codes. What I do, there are two nodes, one temp which is before that, and there is one right new node after that. New node data will contain the data which you have passed. The right will always contain null, and the left will point back to the temp. And there, what we are going to do is that I am going to return the head reference, and the temp of right will point to new node because I have to also connect the temp of right with the new node. Therefore, and that's all. The function is over, and the function is over. That means these are two things I have done. Insert at end. I first of all check whether English does not exist. If it doesn't exist, you have to do this. If it exists, you have to do this. Okay. Before that, you have to do a traversal. Okay, you are asking that if it is not going to modify. Okay, since inserted function does not modify head ref, can we make it a void type? You can take it as a void pointer. Obviously, you can take it as a void pointer, but there is no definite advantage for that. You can do that. You can use it as a void pointer because you are just using it just to return the value. Now I will use a print double linked list. It's the same thing. I just declare a temp type. Temp is equal to start node. Now I am passing the head node to a start node variable. Now this is nothing but a head ref only. Now while temp is not equal to null, printf temp of data and temp being a temp of right. That's all. That's the end of the linked list. Therefore, this is nothing but the traversal data you just initialize a temp pointer, make it point to the head ref, or here I used a start node. You can use the same variable also. You can also use the same variable over here, just to show you that there is no need. You can put any variable, and then I have initialized temp is equal to a start node, and then I just traversed it. In the main function, what you do is that you declare a head node equal to null, and what I am going to I use a insert in function, pass the head node as a parameter, and pass the data as 1. And the return type I say back to head. Now this is the essence of the program, that this head is used to pass a parameter to the function, and from there I return the head and store it back to head, so that that head reference is not lost. Otherwise, if you will not be using this, if I will not be using this, the head ref will be lost, because once it goes from insert end back to main, that head will be lost. And once you will again pass this head value, this will pass the value equal to null, because head ref has been assigned to null, and therefore in these cases it will again pass null values. Therefore, I have to save this into a variable in the same variable like head. Okay. Now I am going to insert 1, 2, 3, 4, 5, and I just call this one. And right now, what I am going to do, I will be just not using this. I will make this the end one. I will just make it a, and now I compile it. Okay, the compilation is perfect. It's 2.4 seconds. Now I am running it. See, it creates a double linked list with 1, 2, 3, 4, 5. And therefore, the linked list is created with 1, 2, 3, 4, 5. And therefore, it is nothing but you insert first node 1, then second, then third, then fourth, then fifth. That means it is going to insert like it. I'll just give you a brief introduction in the mode, because you have already done this. It will be like this. That's all. And this is the head reference. And therefore, this is the, you are going to use the head reference. Now 1 is inserted. Then that is the, it is just using this like this. That means you insert all this at insert at end. One question asked by sir, if a double linked list also shows the data like single linked list, what is the use of it? Batao. What is the use of a double linked list? Yes, that's correct. You can traverse in both the directions, because if I told you, if you have attended that class, if I want to use something like this, I cannot do it using a single linked list. Therefore, I can do like this. Okay. Therefore, not only double linked list, it could be an n-way linked list. I can also have like this, which is very, very practically oriented. This is four-way linked list. Now I might write over here some value. Now let me just tell you like this. I might write say 5, say 20, 50. Okay, and this is a linked list with number of pointers is equal to 4. Now what is this is? This is a node which contains 4 data, four pointers and 3 data. That means it's a 4-way. Now what is the meaning of 4-way? This is study the tree. Now this pointer, this one, will point to all value less than 5. This will point to all values greater than 5 but less than 20. This will point to all values greater than 20 but less than 50. And this will point to all values greater than 50. That means these 4 pointers can point to all values, say from 1 to infinity. All values less than 5 will be pointed by the left one. All values between 5 to 20 will be pointed by the second one, and so on. Therefore, I can declare a particular linked list like I can declare like this. Where this can become, this starts with a pointer 1 and this one becomes a pointer n. We'll have n pointers. If there are n pointers, how many data will be there? N minus 1 data.
N minus 1.
That's all. Therefore, it's very, very useful that n might become 1000 also. And you will study in databases, then databases, when we are going to index a database, the value of n becomes 1000, 2000 also. Because I don't want the tree to become very deep. I don't want to make it deeper, I want to make it fatter. For that, I will make n more and more. If I am going to make more and more, but I don't mean to say that every time you make it very high. Depend on how much is the height of the tree. You don't want the tree to be a very, very big height. Then what I am going to do, I'll put an n such that the number of items, if I have say 1 million, and if I take it say n is equal to 2, the height of the tree will become unmanageable. Therefore, I increase the thing. And this is one of the very important concept. This is called a B tree. It's called a B tree. What does B stand for? What does B stand for? Balanced trees, not binary. B stands for balanced. So balanced trees. Balanced trees means the height of the leaf nodes are at the same level. Okay. Now, I think this is clear. Now the second algorithm, what I will be doing, I will be doing a delete one. Then what I will be doing, I will be first deleting this one. Then I will be deleting this one, and deleting this one, and keep on doing. For each of them, you require a traversal. You require a traversal. Now let me show you the algorithm. Let me show you the programs. Okay. Now this is the program for deletion. It's quite simple. Delete end. I will just require the head reference. I don't require the data because you have to delete the last one only. Then I declare this is not required. If I just used because of the fact that I have used, therefore this is not required at all. Then I just declare a temp pointer. If head reference equal to null, can't delete because there is no node. There is no node to delete, and I return the head reference. Then otherwise I'll copy temp to head reference. Now I perform a traversal. This is nothing but a traversal. Now I traverse to the end, but what I do after end, I come back once. I come back one node. Just because I want to read the last node from one before that. Therefore, I reach to the last and then I just came one back. So the temp points to the node before the node to delete. That means it points to the last second last node. Okay. And then I am going to put the right one as equal to null and therefore return the head ref. I will just return the head ref. And also I will be using a free temp, free what? Free temp of right. Therefore, before making it null, I'll be using it free of temp of right. And this is the simple code for delete. That means delete. You this is a traversal code. Is for traversal. And this is the therefore just come back one node and this is it. And in the function, what I will do, I will remove this one. Therefore, what I do, I am going to use the same thing. Head is equal to delete end of head. Traversal after one element, I just print again the same date print, and then I will just compile it. I just LD return one exit status. some sharing issues were there. Now it's fine. See, the list is 1, 2, 3, 4, 5. After deletion of one element, it gives you 1, 2, 3, 4. After deleting one more element, it gets 1, 2, 3. And therefore the program is perfectly working. I insert 5 elements, then I delete one element, then I again delete one element. Now, moment you want to increase anything more than this, what you do? You just go here. And do is that see, it's going to insert 1, 2, 3, 4, 5, 6, 7, 8, deletes 8, deletes 7, and that's all. Fine. The program is perfectly working. Now, what you can do is that in this code, if you want to insert any more functions, I might write like this. Say and you can directly write a function like this. You just write a function. Therefore, what you can do is that write okay. Now you write another function over here, and in the main program you write a menu-driven program where I write 1 to insert a node at end, 2 to insert a node middle, 3 to delete a node, and so on. By that switch case, you can write a switch case, or you can write a nested if, and you can just build the program like this. Keep on doing, and you'll be able to run the programs yourself. Okay. Now, in that case, only thing is that you make sure you understand that why they use like this. Just because I want to. Now, if you are going to use a turbo compiler, now you can very easily use the global variables. But don't try to limit yourself to global variables, because that might look easy, because I can remove all those things over here. I don't need to pass a parameter. Even this parameter which I am going to pass will become this is not needed. But that is ultimately not going to help you out, because globals are very much discouraged, and global variables are never used in programming at any good level. It's just for starting people who want to learn the starting programming, and once they know the things, they have to never use a global variable, because for a smaller program it might work, but for a bigger program this is going to give a very big problem when you are going to write a program which contains say 50, 100 functions, and you cannot know who has manipulated the data. Therefore, that's the thing. Okay. Now, these are the same code. Now you just keep on adding functions over there. I think one of student already set a code quite early, where which was done. Therefore, you just keep on adding it. So I just post this on the classroom group. Download this and just keep on adding over here. What you have to do is that in this part, you just make it a menu-driven program. just make it a menu-driven program, where you can write a menu-driven, and then you know that how to do that because already done in the last semester how to do a menu-driven program. Okay, now tomorrow we'll start with a new chapter. Maybe I will have some questions over there. Let me see. Therefore, we'll have a class in the next week. After that, next to next week, there will be no class because I'm out of station for some time. Therefore, there will be no class on second, third, uh, 6th, 7th, and 8th. 6th, 7th, and 9th. 6th October, 7th, and 9th October, there will be no class. And then we'll resume from next to next week. Therefore, already 24 classes has been taken. And therefore, I think we'll be sticking to more than 50 of them because that's a good time I'm getting to finish it off. And therefore, we'll do a lot of problems to you.
Excuse me, sir.
Yeah.
Sir, please forward the screenshot of that program if possible.
No, I'll not. I will share the code itself. You don't need to screenshot. I will just share